This question actually splits it into two, where we calculate the Pearson correlation, and then we answer whether or not this correlation is statistically significant. So what I'm going to do is I'm going to follow their guidelines, and calculating the Pearson correlation is step 3 of the hypothesis testing procedure. And then I'll go back in part B and do step 1, 2, and 4 of the hypothesis testing procedure. Okay, so for step 3, we have two options. We have two formulas, so when we calculate the sum of products, we can either use the computational formula or the definitional formula. And what I'm going to use in this demo is the computational formula. Computational formula is the one that you're likely to want to use if your means have decimal places. Ours don't this time around, but I'm still going to use it. I still think that it's worthwhile having a demo using that. So our data, organizing our information, it's going to be tricky with my whiteboard being as small as it is, but I'll make do. Our X values were 1, 1, 4, 3, 5, 2, 5, 3, 1, 5. I'm going to leave a space here because I need to add another column. And our Y values that are linked to these X's. So the participant who had a measure of 1 for the weight had an income of 115,000. And we had 78, 53, 63, 37, 84, 41, 51, 94, and 44. The computational formula, what we need for the computational formula of the sum products, SP equals the sum of X, Y, so X times Y, subtract the sum of X times the sum of Y divided by the number of scores, the number of pairs of scores that we have, how many people answered. And from each participant, we're getting a weight and an income. So to do this, we need a column. Put it over here, X, Y. We're going to take each X score and multiply it by the Y. We need that for here. Then we're going to add them all up. We also need to add up all of our X scores and add up all of our Y scores. So X, Y. 1 times 115 is 115. 1 times 78 is 78. 4 times 53 is 212. 3 times 63 is 189. 5 times 37 is 185. 2 times 84 is 168. 5 times 41 is 205. 3 times 51 is 153. 1 times 94 is 94. 5 times 44 is 220. So if we need to take the sum of each of these columns. So the sum of X, 1 plus 1 is 2, plus 4 is 6, plus 3 is 9, plus 5 is 14, plus 2 is 16, plus 5 is 21, plus 3 is 24, plus 1 is 25, plus 5 is 30. The sum of y, I'm not going to do that quite the same way. But what it is 115 plus 78 plus 53 plus 63 plus 37 plus 84 plus 41 plus 51 plus 94 plus 44. And if we add those all up, we get 660. And then we need to take the sum of xy. So this column here, where we multiplied the x times the y, and then we need to add them all up. So 115 plus 78 plus 212 plus 189 plus 185 plus 168 plus 205 plus 153 plus 94 plus 220. We add all of those up, and so the sum of x, y is 1,619. And with these numbers, we can calculate our sum of products. So we take 1,619. Sum of x is 30 times 660 divided by 10, because we have 10 scores here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So 1,619 subtract 30 times 660 is 19,800 divided by 10. 1619 subtract 1,980. 1619 divided by 1980. Not divided, my bad. 1619 subtract 1980. Negative 361. Okay. So we now have our sum of products. And I'm going to write that up here because I need more space on my board. So the sum of products is negative 361. And that makes sense. We are looking for a negative correlation, right? So a correlation, the correlation R is the sum products divided by the square root of the sum of squares of x, which we now need to calculate, times the sum of squares y, which we also need to calculate. Your sum of squares are always positive. So if your correlation is negative, your sum of products is going to be negative. And remember our scatter plot, we're expecting a negative correlation here. So now I need to go in and calculate the sum of x and the sum of squares, or sum of squares x and sum of squares y, before I can do my correlation itself. I'm going to use the computational formulas for sum of squares x and sum of squares y, because I might as well, right? I already have parts of it done. So sum of squares x, that is, the formula for that is the sum of x squared, subtract the sum of x squared divided by the number of scores. So I need to square all of my x values, which is why I left a nice little space here. So 1 squared is 1, 1 squared is 1, 4 squared is 16, 3 squared is 9, 5 squared is 25, 2 squared is 4, 5 squared 25, 3 squared 9, 1 squared 1, 5 squared 25. Sum of x squared Just gonna pause right here for a moment. Okay, so life interrupted me there. But where I think I was at is in order to calculate the R, I have the sum of products, but I need the sum of squares of X and the sum of squares of Y. So what I'm going to do here, the sum of squares of X, sum of squared scores, SS, sum of squares, I need the sum of X's squared. And to calculate that, what I do is I take each of these values, 1 plus 1 plus 16 plus 9 plus 25 plus 4 plus 25 plus 9 plus 1 plus 25. And I add those all up, and that comes out to 116. So what I can then do is I can put that number over here, 116, subtract the sum of X was 30 squared divided by 10, because that's the number of scores we have. 116 subtract 30 squared is 900 divided by 10. So 116 subtract 90, just 26. So the sum of squares for X, that up here, is 26. Then I need the sum of square for Y. And I'll use essentially the same formula, but with Y in there. So sum of squares Y is the sum of the Y squared, subtract sum of Y squared divided by N. So I need Y squared over here. And I've got all these written out in order to be a bit more brief in the timing, because I don't know about you, but I cannot square 115 and get the right answer. So 115 squared is 13,225. 78 squared is 6,084. 53 squared is 2809. 63 squared is 3,969. 37 squared is 1,369. 84 squared is 7,056. 41 squared is 1,681. 51 squared is 2,601. 94 squared is 8,836. And 44 squared is 1,936. And of course, you can pause at any point and do the calculations for yourself. I'm going quickly because I already have it written out so that this video isn't like 40 or 50 minutes long. But for you, what may be beneficial is to pause it, do the work, then watch me, then pause it, and go back and forth. Adding up these 10 numbers, the sum of those Y squared, so each Y squared added up, is 49,566. So to compute the sum of squares Y, it's 49,566. Subtract the sum of Y was 660 squared divided by 10. Let's see if I can find a pen, a marker that works consistently. So 49,566 subtract 660 squared is 1,900, or 19,800. And then it's divided by 10. Is that right? No, that's not right. I'm looking at the wrong part. Hopefully you caught that. So 660 squared is 435,600. And I could tell that something was off because when I divided the other number by 10, I could see that my sum of squares was still going to be like over 40,000. And I knew that that was likely bigger, given that the sum of squares of x was 26, that was probably too big. And sure enough, it was 49,566. Subtract 43,560, which is still quite large, 6,006. So I'll put that up here. And we'll go from there. So now I have the pieces, and I'm going to actually erase over here now. I'm done with that part. Give ourselves a bit more space. Now I'm ready to calculate my R. Finally. Okay. So my R SP, sum of products, divided by the square root of the sum of squares of x times the sum of squares y. Sum of products was negative 361 divided by the square root of 26 times 6,006. Negative 361 divided by the square root of 156,156. I'm going to double check that. My handwriting's a bit sloppy. 26 times 6,006. 156, 156. It seems like a kind of strange number, but it is what it is. So I take the square root of that number, and I get divided by 395.17. Negative 361 divided by 395.17. Negative 0.91. Your correlations are always going to be between -1 and +1. If you get something outside of that, you done something wrong. So that's all of step 3 of the hypothesis testing procedure. What I'm going to do now is I'm going to share my screen again. I'll start a new video, share my screen, and we'll then go through step 1, 2, and 4 of the hypothesis testing procedure, which is part B of this particular question.